And there's a lot of different styles. So I've separated them up into 2 days so I can show you an example of every single style. Okay? So that means that's the majority of your test is what I'm telling you, is those kinds of things. What I'm going to do today is then we go into exponential functions, logarithmic functions for 2 days, and then 2 days of equations, and we're done. But this is the weird stuff. It is crucial for your survival if you have to take like business count, things like that. If you need nothing from this course but to survive it, and maybe take one other math course that could be MGF 1106 or you know what I mean, then you'll probably never see this again. Yeah, I know. I see how saddened you are by that. This is it. So you're just looking to get out of here alive. That's why you really want to do that grade analysis.
Well, I'm just okay, so I'm not worried.
There you go. It's good to see the light at the end. That's not an oncoming train. Okay, so inverse functions. Inverse of a function is literally what one function does, the other function, the inverse will undo. So if you have a function that adds 2 to everything, the inverse will subtract 2 back out. Okay? Graphically, you will be looking at points that are reflections across the line y equals x. So for example, in this one, the coordinates of that point are 1, 4. The inverse to that point would be on the other side of the line, and it would be 4, 1. So you go 1, 2, 3, 4, 1. So they are mirror images of each other across the line y equals x. In other words, if you were to fold this paper, if you were to ink that blue line out and crease the paper on the dotted line and then open it back up, what would be traced out on the other side of the line? That's the inverse. So when I have something like this, I can do this point by point. I can say, okay, this one is -1, 2. So the one over there that would match it would reverse the x and y coordinates, and it would be 2, -1. So 1, 2, -1. The one over here is -3, 1. So the reverse version over on this side would be 1, -3. So I would go 1, 2, 3. And then I'd have, sometimes I have to count wrong, you know how it is. And then down here finally I have 1, 2, 3, 4, and down 2. So this is -4, -2. So that means across here on the other side. I have to do this to get it off that picture mode, it'll drive me crazy. I've got the reverse of that, so it's, -2 and -4. So I go -2 and 1, 2, 4. So that's not right. Oh, -2, thank you. -2, oh, that -2. 1, 2, seriously, it's sad. Okay, so I get mirror images of the 2 functions. So what I'm doing here literally is just reversing coordinates. I literally interchange the x and y coordinates, which is how we can also do it algebraically, to come up with equations for this. One of the first questions is, if you're working with an inverse function, how do you know that when you reverse the coordinates, you end up with a function again, okay? Because you don't have to. The thing I'm looking for to assure that that's going to happen is what's called a one-to-one function. So remember back in the day when we were defining a function, to define a function, we had what was called the vertical line test. You had this on one of your exams. I think this was the second one. And you would just have a picture. And I would say, yes or no. Is that thing a function? And the test was, if you dropped lines vertical lines and it only crossed one time, you had a function. To make sure that when I reverse this, when I do the mirror image of this across the line, my line y equals x, I have what's called a horizontal line test. For the horizontal line test, that means now I'm going the other direction. If I take a line through whatever I'm looking at, and it only intersects one time horizontally, that means the inverse is a function. Functions that have that property are called one-to-one, okay? This one, even though this is a function, because if I were to drop a line straight down, it never hits anything, but it fails the horizontal line test. If I reverse this, it actually does something like this. So if I reverse each coordinate, I get something that's not a function anymore, okay? So the inverse is not a function. This one, if I take a horizontal line, okay, that means the inverse is a function. So that's graphically. I can also do this by plugging in numbers. A function is one-to-one. If you pick two different numbers and plug them in, you get two different answers out. Yes, sir?
If they intersect once, just like the vertical line test?
No, I'm not testing if it's a function, I'm testing if it's one-to-one.
Oh.
What it means is if it only intersects once, when you do the mirror image, that will be a function. But this is already a function all by itself. In other words, it's already a function, and if I were to flip every single point on this, what I create by doing that is also gonna be a function. This one is a function by itself, but because the horizontal line test fails, when I reverse every single point and get this graph, it's not a function. So you don't necessarily know, just because it's nice, it's a function now, doesn't mean if you start flipping all the points, what you create is going to be a function. That's what this is determining.
Yes. You include the horizontal test on the original function?
Yes, on the original function. To see if that function will have an inverse function. You can have an inverse, period, no function, for anything. You just flip every coordinate. But if I want to specifically create something that is also a function and an inverse, I have to check with a horizontal line. Or I can do this definition, which don't worry, I'm not gonna ask you about. It says, if I put two different numbers in, I get two different numbers out. So if I put in a 2 and a 3 into something, and I get two different answers out when I do that, then what I'm looking at, I'll be able to flip, okay? So, don't even think about that. Here's what the real test is gonna be, and this is the test question. If I give you two functions and I say to you, are these things actually inverses of each other? Will one undo whatever the other one does? The test for that is to do compositions with each of them, and both times get an X for an answer. In other words, it's like I put in this, I have this function box that paints everything red. I put something in, it gets painted red, and then the next function box removes red paint. So I put it in that one, the red paint comes off, and what I input over here is what I end with over here. It has stripped away whatever was done and give me the original input is now the same output. So, notice the notation here, this f to the minus 1, that does not mean this. Okay? In other words, in function notation, that's not 1 over f. F inverse is the symbol for inverse function. It's not an exponent symbol. So, see if these two are inverses. This means if I were to draw them on a graph, and I could ink one, fold it, and it would give me the other one. So determine if they're two inverses. So I have to do F composition G. So that means I put G, which we should be pretty good doing this too by now, into F. So that's gonna give me x minus 6 plus 6, which equals x. So there's one direction that works. And then I do G composition F. So now I put F into G. That's gonna give me x plus 2 minus 2, which equals x. So the answer is yes. I start with an x, I do the composition, I end with an x in both cases. So what would it look like if they're not gonna be inverses? If I do F composition G, add the composition sign, here, that means G goes into F, so 5x plus 1 into the top of that fraction. So I get 5x plus 2 over 5. Well, that ain't x. If I tried the other way, that's enough to tell me it's not gonna work. If I tried the other way, now put the fraction in to G. 5 will cancel. X plus 1, x plus 2. So it wouldn't matter which way you started first. No, not inverses.
Why do you pick?
Because they don't give me x. Definition of being inverses is when you do the composition, you have to get x. This is what has to happen. If that doesn't happen, they're not inverses of each other. One of them did not undo what the other one did. I put an x in, and I got out 5x plus 2 over 5. That means they're not reversing each other. So, here's what you're gonna have to do. You're gonna have to find an inverse. That's how you test to see if it works, but you're going to need to analyze it and find one. And it seems like a lot of steps, and I've got them one by one here so you can see, but let me show you, it's not bad. Okay? So, first step, write it with a Y. You don't want that f of x in there, you want x and y, so they look like coordinates. The next step is, you're gonna reverse the two of them. Literally what I did in that first problem, where I literally reduced the two coordinates. So what I'm going to do is make this the x and that the y. Now I'm gonna solve for y. So that means I need to multiply by 2, because I don't need that denominator there annoying me. Put the 4 on the other side.
Lesson.
Okay.
Solve for y.
What I do here,
The very beginning.
I just,
No, when you put solve for y and then you started with the bracket.
I'm multiplying by the common denominator to eliminate it. Here, that is my F inverse, I think. To prove it, I need to show that F composition F inverse and F inverse composition F, when I do it for both of them, I get X. That tells me I did it right. In other words, it means on a test, you have to know whether you have the right inverse or not, because you can actually show that it works. So it's not a question of, oh, I'm just gonna guess. You create it and then you make sure that it actually works. Okay? So if I do F composition F inverse, that means put this up here. So that's 2 plus 1/2 times 2x minus 4. This is my F inverse, okay? So that is 2 plus x minus 2, that's x. So that one works. Now I do F inverse composition F. So into F inverse, I put F. So, oops. So now F is going in there. And I do the same thing. This is 4 plus x minus 4, which is x. It works. Okay? So I can say the inverse is F inverse of x equals 2x minus 4. And if I wanted to draw that line, it would be the exact mirror image of the little blue line that I already have up there. So this is how you find it. And this is how you make sure it works. Notice you gotta do the composition both ways. You have to make sure that both directions, either way you plug these things in, you always get back the same thing as okay. So, anything that, as long as it's a function, can be here, right? So, this is f of x equals x squared plus 3 for x greater than or equal to 0. I'm going to show you why that little restriction is on there. First step is to say, you call this a y. Second step is you reverse the x and the y. Third step is to solve for y. Okay? Switch. So now I have x minus 3 equals y squared. And when you have a y squared, that means you're going to have plus or minus the square root of x minus 3. Okay? So what this is telling me is that I'm only going to take the positive one. Otherwise, I wouldn't have a function, because you can't have y equals plus or minus something. We learned that in our little function inventions. So y equals the square root of x minus 3. That's my f inverse. Allegedly. So now I have to check and make sure that's actually true. So I'm going to do f composition f inverse. So that means put the square root into f. So the square root goes in there. So I square the square root. X minus 3 plus 3, which is x. Good. Then I do the reverse. F inverse composition f. So I put the square into here. So now I'm going to put under here instead of x, x squared plus 3. This is f. So that will give me the square root of x squared, which is x, because x is positive or 0. Okay? So they both work. So that means, yes, that's a function. That's the inverse function. If I were to look at it, it would look like this. That would be f inverse. I'll do minus sign of all these. This would be f. In other words, that's actually would be a parabola normally, but because of the restriction over there to the side, that restriction is there to make sure that when I reverse it, it's still going to be a function. Because if I didn't have that restriction about x being positive, this thing would look like this, and it would fail the horizontal line test. So that's in there is to make sure that I can create a function. So most of the time, those little things on the side, I know you start to obsess over why is that there or this there. Those little things, those little sidebars are not going to be used in your solution. They're there to tell you that what you're looking at how to restrict it, so if you give pluses or minuses or things like that, yeah.
When you input it, invert back into the original equation, right?
Yeah, because that's what you have. That's F inverse into F. That's the composition that way. And then, yeah, go ahead.
Why did you put brackets in the question before? Like, what is that? Like, what does it mean?
I'm clearing the denominator.
Okay, so you just put like brackets?
No, I'm multiplying everybody by 2.
Okay.
See, I'm not sure. Let me see. I put it in red, maybe? I don't know. I mean, I have a denominator of 2 that I want to get rid of, so in elementary equations, you multiply both sides by 2. See? 2 times x, 2x, 2 times 2, 4.
Brackets and then anything separate from the parentheses.
I just happened to draw that.
Okay.
I didn't even think about it. I think I usually draw brackets when I'm doing that, just because I need them bigger, sometimes, I don't know, I have no clue. It was a total whim, but clearly people didn't like that. Everybody's going, no, it's the second time I get asked it, so clearly I need to fix it. Okay. It's not just you.
I have a question.
Yes?
Whenever you find the inverse, will it always check out as long as you did it correctly? Or?
Yes.
Okay.
In other words, you are finding the inverse. You're claiming this is gonna work. This is
Oh,
the
yeah?
proof to show that that is in fact.
I came in for one
Just like
question.
you saw
Oh,
the
fast as hell.
equations to me and they read it correctly. We'll go back and check it. Good check. That's awesome.
She already. Is that attendance up there? Yeah, yeah. Well, I don't know what the attendance is. Let me see it go around.